So my name is Henrik. I am the CEO and co-founder at Puraffinity, which is a spin-out from Imperial College from 2015. We were founded after coming second at the world's biggest synthetic biology competition called iGEM. I then got gently coerced to take the CEO role after doing an 1851 Royal Commission Enterprise Fellowship. That helped us start the company, and me and my co-founder set up from 2016 with our own labs and our own offices at Imperial. We basically developed precision tools for water treatment capture of specific contaminants. That allows us to use these molecular receptors that typically would be targeted towards developing a new vaccine in the space of sustainability and water treatment. So we have been working on an asset that captures an industrial chemical called PFAS for the last 4 years. It's commonly known as a forever chemical, and they basically stick around with a very high persistence. They have higher toxicity than arsenic, and they are found ubiquitously in a lot of water bodies. So we serve airport markets, we serve groundwater remediation, we work on residential solutions. The way we differentiate ourselves is by having an approach to a bottom-up design of the materials. So we design materials the same way you would make a targeted vaccine or targeted medicine. We use supramolecular chemistry to design the material itself. That allows us to have a bio-based material, and at the end of the life cycle, you can unclick the chemicals that are bound so that you can reuse the material we have made. The material looks like a small engineered sand, so you can imagine it being filled up in a steel tank, and basically the water flows from the top to the bottom. Right now, we solve an issue that was highlighted in a blockbuster movie this year called Dark Waters. So Dark Waters was about this PFAS lawsuit in the US with DuPont, where they have been discharging an industrial chemical, the PFAS, and basically the local community gets ill. It ended up getting settled with a $700 million lawsuit just for one factory discharging that chemical. And we basically solved that problem by providing water treatment to factories or airports or sites that have been contaminated. We've been growing for the last 5 years, so we're now 14 of us working full time. We had the joy of doubling our labs and offices during the pandemic here in White City. And our key milestones include raising a venture round of corporate strategic investment and UK-based venture investment in 2019 of £2.8 million. That was our seed round. It was based on our superior competitive performance for the PFAS asset in a lab. And now we're working with partners and with US-based direct sites to demonstrate those results in the field. We call them field trials. Our immediate key milestones are focused on becoming a capability partner. So the people we work with currently, they have a lot of different needs for contaminant groups to be removed. One of them is PFAS. We want to establish ourselves as a capability partner. So we can remove PFAS as one group, but we can also design materials to capture other chemicals to address new emerging concerns, whether they are pharmaceuticals, pesticides, or another high-impact contaminant group. The field trials are crucial for us, so these form the case studies. We have been working with a German airport, which is one of the leading airports in Europe for the last 2 years, and they're now bringing in the local utility treatment. We will also be working on a residential work stream where basically we partner up with existing companies that sell residential cartridges for under-the-sink solutions, and we would supply the materials that go inside those cartridges as a way of leveraging this material we're developing. Our final goal is to have a large UK-based manufacturing site, an R&D center based in the UK, servicing these verticals with a significant amount of exports. We are not interested in just going through a trade sale, and we have brought in strategic investors from the US that have the capital to deploy across decades, which we're very interested in. So whether that leads to remaining private or the hurdles of an IPO, we have yet to uncover. The way that Bessemer Society is helpful for us is that we are a hard tech company. We combine supramolecular chemistry with data science, with analytics for how these materials perform. And there are not many like-minded entrepreneurs in this space. So people that understand manufacturing, people that understand the operational challenge of combining disciplines, and then also the nitty-gritty of talking to decision makers at other sustainability-focused organizations. The last example was getting help with a lab tech apprentice and whether there are any other jobs or manufacturing sites we should be engaging with. It's really helpful for that.